Hi, today our topic is sketching of linear inequalities in two variables. With this, I say you are welcome to mathematics. At the end of this lesson, you will draw any two variable linear inequality. 2. Show the region that satisfies an inequality of two variables. Before we dive into the topic for today, please I want to or encourage you to watch videos on ways to sketch a straight line graph as shown here. So there are videos anyway. There are previous video. Please watch them because this serves as a prerequisite for us to being able to um, survive this topic and to be able to understand this topic better. Let's discuss about steps to sketch a two-variable linear inequality graph. 1. Sketch its equation using a broken line for greater than or less than, or solid or unbroken line for when we have less than or equal to or greater than or equals to, which divide the graph into two parts when dealing with just one linear inequality graph at a time. So that's the first step. The second step is to test a point outside the line. We pick a point outside the line of the inequality, we test it. So if test comes out at false, we shade the region or side of the point. Please observe that the line has already divided our graph into two parts. So wherever the point is, if the test comes out as false, we shade the region of the point. But if it comes out as true, we shade the opposite side of the point. Note, the unshaded side is the required region. In case of simultaneous linear inequality in two variables, so as to give a clear region, required region. So that's why we decided to shade the um, leave the required region blank. You appreciate this when we get to simultaneous linear inequalities. We start with an example which says show the region that satisfies x plus 3y greater than or equal to 6. Okay, we review our step summary, which is number 1, sketch its equation using broken line for greater than or less than, or solid line or unbroken line for greater than or equals to or less than or equals to. Now we test the point outside the line. Most of the time we use 0, 0 if the line doesn't pass through 0, 0. Okay, so if the test comes out as true, we shade the opposite side of the point, and if test comes out as false, we shade the side of the point. Note the unshaded region is our required region. Let's have a solution. Please, you are encouraged. You can give this video. You can pause this video just to give this question a trial. Okay, moving forward. Um, let's draw our x and y axis. Okay, so we want to know where x is 0, what value of y, and when y is 0, what value of x. So as we can see, when x is 0 here, so we can divide both sides by 3. Why? We are actually sketching its equation, so I don't really consider the sign yet. Okay, so once we divide both sides by 3, then 6 divided 3 divided by 6 gives 2. Okay, so that's why we are having a 2 here. And for the other hand, when y is 0, it's obvious that x equals to 6. Okay, when y is 0, it's obvious that x equals to 6. So that's why we have those 2 points over here. Then we join them with a line. The type of line is surely a solid line. Why? Our inequality is greater than or equal to, which points or tells us that the boundary is also included. The boundary is also included. Okay, so we test a point outside the line right now. We test a point outside the line. Say the origin, actually, the origin, as you can see over here, which is 0, 0. So we test 0, 0 on this inequality. That is when x is 0, y is 0. So 0 plus 3 into bracket 0 greater than or equals to 6. At the end of the day, the left hand part here is 0. So 0 is greater than or equals to 6. That is logic. By logic, this is false because 0 cannot be greater than 6. Okay, since it is false, what does it say is we shade the side of the point. That is, observe that this line has already divided the whole graph into two parts, the down part here and the upper part here. So we made a test at this side of our graph, and we got the result as false. Therefore, we shade this side of the point. That is, as you can see here, let's shade it. All right. Now, this black shading shows that this the other blank part, the unshaded, will be our required region. So we give that a letter. Then we write a conclusion that therefore the region R is our required region. Note, this question says that we should show, and showing here is what is the real deal, is our activity. It's not just enough for us to shade one part and just conclude that, okay, the person marking we or assessing me will know that the unshaded region is a required region. So you're meant to write it out as, okay, therefore the region R, this could be any letter of your mind, maybe KL. So the region R is the required region. I hope this is quite clear. We want to say a very big thank you for watching this video. You're highly appreciated. Please feel free to comment your questions and give this video a like and subscribe if you haven't. Share with your friends. It's valuable lessons that we are learning here.